want to solve questions on chemical equilibrium, and this is to help our understanding of chemical equilibrium. Alright? In connection to this topic, we have also discussed chemical energetics. So, questions on chemical equilibrium looks like this. Number one, please, let's read together. Now, questions look like this. In the manufacture of ammonia by the reaction N2 gas, N2 gas plus 3H2 gas, 2NH3, alright? Enthalpy is minus 92.37 kJ. The amount of ammonia formed at the equilibrium will increase if, alright? So this is the reaction that shows the production of ammonia, okay? And the question is, the amount of ammonia will increase, alright? If, alright, so look at the option. The pressure decreases, the temperature decreases, the temperature increases, the catalyst is used, the physical state of the reaction are changed. Now, when it comes to chemical equilibrium, alright, there are factors that affect chemical equilibrium. We have pressure, we have what? Concentration, and we have what? Temperature, okay? Now, you can see this is negative enthalpy change, alright? So, what does negative enthalpy change mean? Negative enthalpy means that heat is given up to the surroundings, okay? So this is the amount of heat that is going up from the surrounding. You understand? So if heat is given up to the surrounding, it means that the reaction does not proceed with increase in temperature. The condition that will favor, alright, the increase of the product for an exothermic reaction is when we cool down the environmental temperature. Are you getting me now? Because it's already exothermic. So that minus shows that what exothermic is giving out heat. Are you getting me now? So when you hold the temperature around the environment, it will favor the forward reaction. Are you getting me now? Vice versa. When you increase temperature, it will favor backward reaction. That is general for all exothermic reactions under equilibrium conditions. You understand me now? So we say that the equilibrium position will shift to what? The right, to favor the what? The forward reaction. You get that? Put on the option is correct. The pressure decrease, the temperature decrease. So temperature decrease is the correct what? Option. We decrease temperature of the surrounding. Okay? Now the next one. In the reaction N plus N before reaction P, the current is positive. Okay? Positive kilojoule, which of the following would increase the concentration of the product. So we are talking about increasing the concentration of the product now at what? Endothermic reaction, not exothermic now. The first one was exothermic, now we are talking about endothermic reaction. So what is the condition that will favor it? You increase what? Temperature, because the reaction proceeds by absorbing heat. So increase in temperature will favor the forward reaction. You get that? I think you understand, right? So now look at the option. It says increasing the concentration of N, increasing the concentration of P, adding a suitable catalyst, increasing the temperature, and increasing the temperature. So which one favor? Increasing the temperature. This is the correct option. What about concentration? Now, in order to favor the forward reaction, the concentration of the product must be reduced. Are you getting me now? That is, you will be taking out one of the products, just be removing it. Have a system of removing the product. As it is formed, you are extracting it from the system. Are you getting me now? As soon as you are extracting the product form from the system, then you are reducing the concentration of what? The product. that will favor the forward reaction. Do you understand that? Let's assume for this first question now. If I have a system where I'm removing the ammonia form, the equilibrium position will shift to the right to favor the forward reaction. You understand that? Reducing the concentration of what? The product will favor the forward reaction. So what are we going to reduce the concentration of the reactant to favor the backward reaction? For instance now, we are having what? N plus P, right? If I extract any of this from the system, the equilibrium position will shift backward to favor the backward reaction. You understand that? More of the reactant will be formed if any of this is extracted from the system. I get it now. So that is why when you look at this, that increasing the concentration of P. In order to favor the forward reaction, you have to reduce the concentration. So if I increase the concentration of P, what will happen? The equilibrium position will reverse backward to shift. I get it, it's going to shift backward, which is what? Left hand side to favor the reactant. Is that okay? Alright, so now let's go to the last question. Consider the following exothermic reaction. Now look at this. 2 moles of SO2 plus O2 forward reaction 2SO3. I will be if the temperature of the reaction is reduced from 800 degrees Celsius to what? 500 degrees Celsius. No other was takes place, then what will happen? If the temperature is reduced and no other thing takes place, what will happen? That's the question. Temperature was reduced and no other thing takes place. Now remember, consider the word exothermic reaction. Either you see minus enthalpy change or exothermic. So, if you want the forward reaction, you reduce temperature, right? So you can see, we reduce temperature from 800 to what? 500. So that means that what? More of what? More of the product will be formed because temperature was reduced for an exothermic reaction. Do you understand that? So more of what? The product will be formed. So which of them align to this answer? Reaction rate increases, concentration of SO3 decreases, concentration of SO3 decreases. And SO2 gas becomes all reaction. So C is the correct option.